Hey y'all, Data Guy here, back with yet another viewer request video. Doing a lot of these recently, and I love it because I love making videos that are actually relevant to people and that you want to see. So if you have a viewer request video you want to drop in, please don't be a stranger. Drop it in the comments below. I monitor and get a lot of my video topic ideas from there. So thank you to everyone who does. But today, what I wanted to explore is really just talking about best practices for machine learning operations in production. So this was a comment I got saying, "Hey, can you talk about how people are deploying and managing machine learning models and retraining them on user data?" So I'm going to start with kind of an abstract best practices video, and if there's a specific set of tools, specific use case that you want to see like a deep dive and more of a practical session on, please let me know in the comments below, and we can definitely make that happen. But today, what we're going to be going through is really just talking about at a high level, hey, how do we deploy machine learning models into production, and then go through every step of that life cycle, from design to model development, deployment, packaging, integrations, deployment into, from development to production, retraining ML models on user data, setting up pipelines to continually ingest and clean and store data, and then model evaluation, selection, and then finally going down into the stage of redeploying models. How can you stay on top of monitoring your pipeline, having a consistent consistent pace of iteration on your machine learning pipelines, because that's really crucial to actually having effective current machine learning pipelines. If you train it on data that's even a couple weeks old, sometimes that can screw up your entire use case and your entire model. So we don't want that. So that's what we're going to be going through today. So without further ado, let's get into it. So here I've got that good old A16Z reference ML architecture, just as kind of a backboard so you can see what I'm talking about when I'm referring to deploying an ML model, and really illustrating how many steps you're going to need to track. There are tons of critical steps. You have model training, you have model validation, you have packaging, you have integration, you have to handle model registry, you have to handle compilers, vectorization formulas, vectorization databases, deciding on ML frameworks in general, and really I kind of want to break it down into three main areas that you should focus on, and make sure that you have kind of a checkbox when you're setting up a machine learning environment. And number one comes kind of on the left, which is machine learning model training and validation. So first, data preparation, making sure not only that your data is clean, but making sure your data sources are reliable and have accurate data. And then also, after you've done that, making sure that your training data that you're collecting from those data sources is properly cleaned, it's balanced to remove any bias, but also making sure that's still representative of the real world data that the model will encounter. If you're just cherry picking your data and trying to go to a certain outcome, you're not going to have a good time. Then next, you're going to want to think about feature engineering. What are the relevant features from that data that you want to incorporate in your model? There might be dozens of different characteristics around, let's say, user data, but maybe for your particular machine learning model where you're trying to track sentiment, you only actually want to use 4 or 5 of those features within your model. And so making sure you're identifying the most relevant and actually predictive features from your data, this is an iteration process, will help improve your model performance. And then on top of that, not only to choose the right features to use in your model, but also your model selection. So make sure you choose an appropriate model architecture based on your problem domain and your data characteristics. There are literally hundreds of different machine learning models out there, so I almost guarantee you there's one that's already been fine-tuned to a use case very similar to your own. So go out there and leverage those. And then also just classic basics here, validation, making sure that you're splitting your data into training and validation sets to evaluate models performance and also prevent overfitting of your data. And that's talking about, hey, where you're kind of massaging the data or making sure it's too triangulated on that small chunk of data, and then when it's applied to the larger, broader data set, you might run into issues because it's not actually accurate because you cherry picked that data so much. So that's kind of model training and validation. Then we also have packaging and versioning. So containerization is super prevalent in machine learning because you can use containers like Docker images to package your model, its dependencies, and have kind of a boilerplate standardized image that you and your other engineers can run, making sure you have consistency across wherever you're running those machine learning models. And then also a lot of times when you're running machine learning models, you have to leverage distributed computing. things like Kubernetes, and so having already Dockerized your machine learning models, the dependencies, makes it easy to then deploy it onto those distributed environments for helping you to process that data and run those machine learning models even faster, as well as across a variety of different kind of base environments. And throughout all of this, you're also going to want to implement version control. So making sure you have version control for your models, your code, your data, to track any changes to each of those, have timestamp every single change, and then also have a repository of past versions and snapshots so that you can facilitate a rollback. If you suddenly just completely screw up a model, it's much easier to roll back to a version before you made those breaking changes than trying to reverse engineer and fix what went wrong there. And then kind of throughout this, but primarily within the beginning and kind of this middle step of model training and development, but API development, make sure you have your model wrapped in an API to allow interaction with other applications. This makes it much easier to kind of establish a building block of, you have your model training playground, and then that goes into your feature server, and then that will feed into your batch predictor. And so just making sure that wherever you're deploying your models, just make sure there is an API interface for interacting with them, maybe in REST or gRPC. And that also has the added benefit of allowing you to remotely trigger the models and templatize them. So, hey, I can rerun the same model with just API calls and just changing the data or where I'm pointing it to within that API call. And then to help track and automate all these different changes and also ensure you have good code integrity, implement standard continuous integration and continuous deployment practices. So automate your whole deployment process using CI/CD pipelines. It's not only going to give you smooth and frequent updates, but also give you a way of checking any code changes. It makes it easy to have that kind of rollback repository to previous versions. You can do branch-based deployments and development processes so your developers can develop independently and then all merge back to one kind of gold standard main. And then also, finally, in this kind of section, monitoring and logging. Make sure you're implementing monitoring to track model performance metrics like your accuracy, like your latency, and also capture predictions and errors, just to make sure that you don't have to go digging manually. You have kind of services that, whether upon a failure or a success, are automatically emitting messages that have all the necessary information you need to know to quickly decide, hey, what was the results of this model's training session, what went right, what went wrong, and then that in turn helps you iterate faster and improve on your own processes. So next topic I want to go into is retraining on user data. And so for that, I have kind of a simple example of a retraining cycle that you can implement to actually retrain your models based on new inputs. And even though it says a single user here, you're probably going to want to just batch process these. So you'll collect user interactions for a day, then rerun that model at night. But also have some, I've seen some people have situations where they have individualized machine learning models as well. But in this example, which is what you're seeing in this example. And so in terms of best practices here, 3 categories. You have best practices around data collection and pre-processing, triggering and retraining and how you want to do that, and then also model evaluation and selection. So first, data ingestion. Make sure, and this is super basic, but just make sure you're continuously collecting new data from user interactions. And then also, this has the dual benefit of giving you all that user data, but then also giving you compliance with all the data privacy regulations you now have to deal with when dealing with user data. Then you also have data cleaning. You are never ever going to have, and this is kind of a curation step, but you're never going to have user data come in perfectly clean, ready to be used. I saw a great example of like 50 different spellings of St. Albans in a data set. Like you can have really screwy user data even if you have good checks and controls. Make sure you are removing outliers, handle any missing values, pre-process the data and maintain its quality. Make sure you're not training your model on super crappy data. And then also think about using scalable cloud storage solutions like S3, like Google Cloud Storage, like Azure Cloud Storage, Blob Storage to handle really large volumes of data, because user data can get quite voluminous quite quickly as well. Next things you're going to want to think about are scheduled retraining. So when do you want to set up periodic retraining schedules? That's what I was talking about with batch processing based on the rate of data change and model performance decay. If having it happen weekly is going to mean your data is too out of date for things like real-time analysis, you will want to have a quicker retraining schedule, maybe hourly. So really think about, hey, how quickly do I need this model to be updated in order to keep it accurate? And then also think about implementing performance-based retraining in tandem. This kind of make it less time-based and say, hey, implement a trigger based on your model performance metrics. So when your accuracy drops below a predefined threshold, retrain it on all the user data that was just collected to bring it back up above that certain performance threshold. And then third, under model evaluation selection, use things like cross-validation. So cross-validation techniques to evaluate the retrained model's performance on the new data. And then comparison with that baseline. So compare your retrained model with your existing model to ensure that there is actually a significant improvement and you're not just reiterating and retraining for the sake of retraining. So now in terms of that actual process of redeployment, it's typically just going to look something like this. So you're going to deploy that initial model after you do some model evaluation. Then you're going to collect data based on the end users that are interacting with that model. Then after you've done that data collection, doing that pre-process, doing that analysis again, on whatever kind of time schedule you determine or based on, accuracy, red flags, then going through the section again, selecting the model, training it on the new data, doing again model evaluation, making sure that it offers a significant improvement over the previous model that was deployed. And so some best practices here. Number one, come with the staging environment. So with your staging environment, just have an environment that is separate from production where you can deploy retrained models to test its performance and also compatibility with the production system. So really set it up almost as if it were a production system. And then also go through user acceptance testing. So conduct user acceptance testing to gather feedback from end users and identify potential issues. And that's really what it is like when in ChatGPT where it says, hey, was this response good or not? That's end user feedback collecting. Use that to identify potential issues, say, hey, these are some predictions that actually weren't great, that didn't work out well, and so that way you can know to flag those and say, hey, it looks like we need to look into what in our model is driving these poor predictions. Second bucket of practices are blue-green deployments. So not really similar, but differently from staging environments. You have blue-green deployment strategy essentially has one new model where you deploy the new model, which is the green deployment, alongside the existing blue model, which is the existing model, which is blue, and then kind of comparing them, gradually shift traffic from end users from that old model to the new model, so you're not immediately just hard swapping them out. A good example is like doing a bleed over, so all new requests go to the new model, and all old requests that are already running stay on the old model. And then another option there is doing canary releases. So deploy your new model to a very small subset of your users initially, and then monitor its performance before you do a full rollout so you can catch any possible issues with a smaller subset of users. And then finally, under monitoring and rollback, so make sure you're constantly monitoring the new model's performance in production to detect any anomalies, degradations, anything like that. And then also have a rollback mechanism and a rollback plan in place to revert to the previous model version if the new model fails to meet expectations. So those are all the kind of best practices I have for you today. In general, deploying, retraining, redeploying ML models, it really requires a systematic approach in production to ensure that you have reliability, scalability, and maintainability. But hopefully, using some of these best practices, you can really minimize the difficulties and maximize the benefits of ML models because they are really powerful for predictive analytics. So I hope you've enjoyed this video. Hope you have a great rest of your day. Data Guy out.